Hi everyone. Today we're gonna discuss the topic distributed generation. Power in India terms in business is about balancing demand and supply. As a country, we need constant energy, right? So when we all want to use energy at the same time, what happens? Energy demand spikes, right? For the last year, our energy supply has come from big centralized sources, power stations like coal, gas, and nuclear, and more recently, renewable energy like wind farm and solar overfeeding into the national grid. As you know, our energy demand is also changing. With growth of electric cars and smart technologies can more control over energy use, but they are putting more pressure on the national grid and on our energy bills. So it is viable to look demand and supply in another way using distributed energy, which holds a key to more affordable, secure, and low carbon energy. Our distributed energy in power business helps peak and energy consumers like businesses and hospitals to use energy more efficiently and become small scale energy producers by installing energy efficiency measures, adding technologies like solar panel, combined heat and power, and wind, and also by using backup generators appear to high demand. We can help them to design and store and manage these assets by connecting to them to energy controlling centers. From here, we can help during peak demands that put pressure on the network. During the spikes, our distributed energy customer can actually earn money by generating energy, reducing the consumption or delay in energy use. There is an option of energy storage like battery is also there. This will help to pick energy users to better manage how and when to take energy from or export it back to the utility grid. Distributed energy will replace all large-scale power stations, but it will provide much-needed flexibility and help the customer to tackle three big energy issues. So we can see one by one: lowering bills to energy efficiency and new sources of income, ensuring more secure energy supply and improve resilience, and providing low carbon content energy system. We believe distributed energy has a vital role to play in Indian energy. For economic development of the country, energy is one of the major inputs. By 2030, it is said that electric energy demands in fast developing countries are estimated to triple. As you can see, this is a typical structure of a traditional power system. In this, here you can see a network of electrical components used to supply, transmit, and use of electrical power. So this is a structure of electric power system. So here you can see a generation side, power generation side, and here the power transmission, and here you can see the distribution. So power generation means what? It comprises of generators, right? It will generate voltage, the range of 11 kV to 33 kV, and for that they use generating stations like hydro, thermal, nuclear, diesel, etc. Then comes the transmission. So after the power generated from generating station, it is transmitted via transmission lines, right? So power transmission is in the range of voltage of 110 kV to 20 kV and 400 kV. So here the voltage, the generated voltage is stepped up, and then it is given to distribution side for distribution, and here what happened, that it is stepped down the transmission voltage to consumer levels. That's all about a structure of electric power system. So far we discussed about the conventional power system. As you know, conventional power system is facing the problems of the gradual depletion of fossil fuel resources, the process poor energy efficiency and pollution, environmental pollution related problems, etc. Right? So these problems have led to a new trend of generating power locally at distribution voltage level by making use of renewable energy sources like natural gas, biogas, wind power, solar PV, combined heat and power, fuel cells, etc. And we do integrate this into the utility distribution network. So this type of power generation is termed as distributed generation. It's nothing but it's an approach that employs small-scale technologies to produce electricity close to the end users of power. This type of power generation is termed as distributed generation, and the energy sources used are termed as distributed energy resources. Do you follow me? So the distribution network can be active or it can be passive distribution network. An active distribution network means the power flow is bidirectional. Bidirectional power flow means the power can be transported from utility grid to consumers as well as from consumer side to utility. Passive distribution network means the power flow is unidirectional. That means power can transported only from utility grid to consumer side. So if we do integrate the distributed generators, this distribution network can become active. So according to several research studies, some universally accepted common attributes of distributed generations are: it is not centrally planned by the power utility nor centrally dispatched. Usually its size is smaller than 50 megawatt, and the power sources or distributed generators are usually connected to the distribution system, which are typically of the voltages 230 or 415 volt up to 145 kV. So as I said before, we can do integrate the distributed generation to grid, and this integration of DG to grid is a promising area of research in recent years, because mainly because we make use of renewable energy sources. As you know, it's produce clean and eco-friendly energy, right? Thereby we can reduce environmental pollutions, global warming, so etc. And not only that, this DG system improve the overall efficiency also by enhancing cogeneration. What do you mean cogeneration? Cogeneration means here the electricity is generated wherever it is needed, and additionally it gives the opportunity to use the excess heat for heating and hot water, etc. Okay, and with this DG system, they usually locate close to load, right? So we can the losses associated with this transmission distribution are also negligible. So these distributed resources, they are generally modular units of small capacity, and usually they are chosen for an area based on its geographical condition of the region. Like if the wind is strong and reliable, we can go for wind farms. We can say the area which receives direct sunshine for most of the day, and say it's not shaded by tree or buildings, we can go for installing solar panels. So the source completely depends upon the region, the condition of the geographical condition of the region. And the two types of operations are possible for distributed energy resources: grid connected and standalone operation. Both the mode we can improve our reliability and power quality. And not only that, this DG system offer fuel diversity, because suppose you take a hybrid system like combination of solar, wind or solar, diesel generator, etc. If suppose one source like solar, if there is a shortage of sunlight, we can switch on to the other mode of operation, like getting the supply from this DC generator. Thereby we can assure the continuity of power supply. So what do you mean by distribution network? Actually, it refers to those 22 kV or 11 kV network supplying electricity to customers through cable or overhead line. Okay, so the network configuration would directly affect the supply reliability, and there are a lot of configurations available, and this distribution network can be either active or passive. So coming to passive distribution network, what do you mean by passive distribution network? They are designed to accept bulk power from transmission system and distribute to customers. So here the power flow, that is the electricity transportation, is unidirectional, means electricity transportation is only from utility grid to consumers. So here the consumers in passive distribution network, they completely rely on utility grid for power. So if there is no power from utility side, that's it. They can't get the power. So we can make a passive distribution network an active one. So you know what's active distribution network? There bidirectional power flow is possible, right? So how we can make a passive distribution network an active one? By adding DG units to it. With the deregulation of energy market and the appeal of the environment protection, more and more distributed generation is embedded in the distribution network. So however, the approach of connecting DG in most cases is based on a so-called fit and forget policy, and the capacity of DG is limited rigidly by distribution network operator to avoid the negative effects of high-level penetration. Therefore, active management is put forward as an effective method to network reinforcement for the connection and operation of DG. So a network is active when is added DG and there is bidirectional power flows in the network. The bidirectional power flows require a flexible and intelligent control. Now we have to discuss about the topic microgrid. Generally speaking, generating stations and grid supply the homes and businesses in a neighborhood. A microgrid can be set up by adding technologies such as solar panels, large capacity batteries, and electric vehicles. Connected devices manage home electricity use. Microgrid technologies can supply homes and businesses in parallel with the grid. If the main grid goes out, the microgrid can continue to supply power to homes and businesses for a while, keeping customers comfortable. When the sun is shining and less power is being used, the microgrid can supply the whole neighborhood or part of it, and if the microgrid generates more electricity that the neighborhood needs, the surplus can be fed back into the grid. Now we will discuss the advantages of microgrid. From grid point of view, the main advantage of a microgrid is that it is treated as a control entity within the power system. So it can be operated as a single aggregated load. This ascertains its easy controllability and compliance with grid rules and regulations without hampering the reliability and security of the power utility. From customers' point of view, microgrids are beneficial for local meeting their electrical or heat requirements. They can supply uninterruptible power, improve local reliability, they can reduce feeder losses, and also they can provide local voltage support. So from environmental point of view, through utilization of low carbon technology, these microgrids can reduce environmental pollution and global warming to a great extent. So what's microgrid? It is a local energy grid with control capability, which means it can disconnect from the traditional grid and it can operate autonomously. So that is the definition for microgrid. And now we can see what are the key differences between a microgrid and a conventional power plant. So in conventional power plants, large generators are used for generation, right? In case of microgrid, micro sources like solar, wind, etc., they are of much smaller capacity when we do compare with large generating conventional power plants. And here the power generated at distribution voltage and it can directly fed to the utility distribution network. And not only that, the micro sources like the solar, wind, etc., they are normally installed close to customers' premises. Why so? So that the electrical or heat loads can be efficiently supplied with satisfactory voltage and frequency profile and with negligible line losses. To achieve a stable and secure operation, a number of technical, regulatory, and economic issues have to be resolved before microgrids can become commonplace. So, some problems areas that would require due attention are the intermittency of distributed energy resources, low energy content of the fuels, lack of standards and regulations for operating the microgrids in synchronism with the power utility. The study of such issues would require extensive real-time and offline research which can be taken up by the leading engineering and research institutes across the globe. A typical microgrid configuration is shown here. The microgrid consists of three radial feeders, feeder A, feeder B and feeder C, to supply the electrical and heat loads. It consists of electrical or heat loads and micro sources connected to a low voltage distribution network. The loads and the sources are placed close together to minimize the heat loss during heat transmission. It also has two CHP and non-CHP micro sources and storage devices. Micro sources and storage devices are connected to feeder A and feeder C through microsource controller. Some loads on the feeders A and C are assumed to be priority loads, that is, it requires uninterrupted power supply, while others are non-priority loads. The feeder B, however, contains only non-priority electrical loads. The microgrid is coupled with main medium voltage utility grid. This is the utility grid through the point of common coupling point circuit breaker CB4 as per standard interface regulation. CB4 circuit breaker 4 is operated to connect and disconnect the entire microgrid from the main grid as per the selected mode of operation. Feeder A, feeder B and feeder C can however be connected and disconnected by operating breakers CB1, CB2 and CB3 respectively. The micro sources on feeder A and C are placed quite apart from the microgrid bus to ensure reduction in line losses, good voltage profile and optimal use of waste heat. Although the control of power flow and voltage profile along radial feeders is quite complicated when several micro sources are connected to a common radial feeder and not to a common generator bus, this configuration is necessary to avail the plug and play feature of the micro sources. The microgrid is operated in two modes, grid connected and standalone. In grid connected mode, the microgrid remains connected to the main grid either totally or partially and imports or exports power from or to the main grid. In case of any disturbance in the main grid, the microgrid switches over to standalone mode while still feeding power to the priority loads. This can be achieved by either disconnecting the entire microgrid by opening the circuit breaker 4 or disconnecting feeders A and C by opening circuit breaker CB1 or CB3. In first option, that is disconnecting the entire microgrid by opening the circuit breaker 4, the microgrid will operate as an autonomous system with all the micro sources feeding all the loads in feeder A, B and C. Whereas if we do disconnect circuit breaker 1 and circuit breaker 3, what happen? Feeder A and C will supply only the priority loads while feeder B will be left to ride through the disturbance.